Okay, so now let's have a review of the conjugate acid-base pairs. So by Bronsted-Lowry definition, an acid is a substance that will donate proton, and base is a substance that will accept a proton. And proton usually denoted as H plus. So why protons is denoted written as H plus? Do you remember why? If you don't remember why, let's just have a quick review of why, okay? So I hope that you remember the structure of a hydrogen atom, which includes a proton in the nucleus at the center of the atom, and then we have another electron moving around, right? So when the hydrogen atoms is written in the periodic table, it will have an H which stands for the whole name hydrogen, and then it also have a little number here at the subscript 1. So why that 1? This little number is called the atomic number, which basically is the number of protons inside the nucleus, because the number of protons inside a nucleus will define what kind of element that atom belongs to, right? Like hydrogen should have 1, or like oxygen should have 8 protons in the nucleus. So other than that, in the nucleus, there are also other particles as well. And if you remember, that should be also like neutrons and protons. That's on the particle inside the nucleus. And then we also have another numbers here that is written in the superscript. And this will be the total number of the nucleons, which just means the particle inside the nucleus, including neutrons and protons. And this number also have another name for it all. That will be the mass number. So why is a mass number? Because the mass of a proton is about 1,800 times the mass of an electron, and the mass of a neutron as well is also like around 1,800 times the mass of an electron. So that way you can see that there's such a huge difference between the mass of a proton and a neutron, right? You can just imagine that this is just like the mass of a little ant, which is around 1 gram, and then you have something like nearly 2 kilograms compared to that little ant. So the little ant is just like nothing, right? Compared to that. That's why the mass of the atom, it basically just include the mass of the proton and the neutron, and the mass of the electron is kind of like negligible compared to them. That's why the number of nucleons is just like the mass number. Okay, so that's also like a quick review of the hydrogen atom, the way we write like this, like H1 and 1. Okay, so we can see that usually for the atom, it should be neutral. Neutral means that the charge should be like 0, right? And we can see that outside we have an electron which have the charge as like 1 negative, 1 minus, because we take the charge of the electron as the unit charge when we're talking about the charge inside a atom at the atomic level. And then we can see that for the proton, it has the same amount of charge, but it's a positive. So 1 positive and 1 plus together, they make it a neutral. And that's why the charge of the whole atoms is neutral to be 0. So that's why usually we can also like write the charge here at the corner, but it's that necessary, right, for the hydrogen atom. So here, come back to the story, our purpose. We want to see why is H plus, right? And now does it make sense to you? Very clear, right? Because basically we just have a proton inside the nucleus. The electron has like gone away to some other place to play with other atoms or molecules. So now we just have one proton left. And now we also have like one protons here. If you want to write it down, but usually they don't write it down, okay? They just write it like H plus. And now let's check the charge. Now there's no electron anymore. There's just the proton, right? So the charge now just like 1 plus. And no minus to cancel out with it like in the atom. So that's why you can see that for the proton, we just write it as hydrogen plus, H plus, or hydrogen nucleus, or this is the hydrogen ion, the cation, the positive ion one. Okay, so I hope that with this picture in mind, you can imagine that basically on the reactions between on the substance, it's just like a kind of like moving around journey of the proton or of the electron itself. Okay, and then with this in mind, we can continue to review about the conjugate acid and base based on the Bronsted and Lowry definition. Okay, see you in the next video.